Okay. Today, inshallah, we are going to discuss discrete probability distribution. This first lecture in chapter 5. Chapter 5 somehow related with chapter 4. Chapter 4, we discuss about basic probability, discuss about sample space. From sample space, discuss about event. We divide event to 4 main types. Discuss about simple event. Simple event consists of one outcome. Then we move to compound event. Compound event consists of more than one outcome. Then we move to certain event, consists of all sample space point. Finally, we discuss about impossible event.
Impossible.
Yes, impossible event consists of empty set, no event. Then we move to type of probabilities. Type of probability, we discussed about 3 types. First type, classical probability. Second type, empirical probability. Third type, subjective probability. Also, we discuss about event operation. Discuss about union, intersection, and complement. This lecture 8. We move to lecture 9. Lecture 9, we discuss 3 main topics. First topic was addition rule. Addition rule about mutually exclusive or disjoint event. If A and B are two disjoint event, then probability of A or B equal probability of A plus probability of B. Then we move to multiplication rule. Multiplication rule, if A and B are 2 independent events, then probability of B of A and B equal B of A multiplied by B of B. Then we move to conditional probability. Probability of A given B equal B of A and B over B of B. Probability of B given A equal probability of A and B over probability of B. This is all about lecture 8 and lecture 9. Today we are going to discuss about lecture 10. Lecture 10 about discrete probability distribution. First, in this class, inshallah, after we finish this class, you will be able to construct a discrete probability distribution for random variable, and also we will know how to find mean, variance, and standard deviation for a discrete probability distribution. Let's explain what is discrete probability distribution and what is random variable. Simple definition of random variable is mapping sample space point to number. Let's take example. For example, if we toss a coin one time, sample space consists of 2 outcomes, which are T and H, right?
Yes.
Yes, T and H. Question is T and H. T and H. This is the outcome when tossing a coin one times. So now let denote 1 for getting T. Okay. 0 for getting H. For getting H. So now we denote a variable, let denoted by X. X equal 1 when we get T. X equals 0 when we get H. So X take 2 value, 0 and 1. Instead of using this outcome, Just we can use this number. Just we can use this number.
دكتور
Actually, we map this sample space, which is T and H, to a discrete value, which is 0 and 1. E with 1, right? H with 0. So you can see just like a function of sample space to a real number. Every point in sample space, we map it to a values or a numbers. Let's take other example. If we toss coin two times, in this case, sample space consists of 2 times. Sample space consists of how many points in sample space?
4
4, which are
تايد and H تايد and تايد
H H H T T H T T.
yes, 4 outcome, which are both T's H and T, first H, second T, or first T, second H, or both H. So this is the 4 outcomes of the sample space. If we denote X, if we define X like number of H, number of H we get when we toss a coin 2 times. So X take which value? X take 0, right? X take 1, right? X take 2. So for T and T, X equals 0, right? For
Okay.
T, HT and TH, X take 1, right?
Right.
For HH, X take 2. So this is the 3 possible values for these outcomes. We call this random variables, and we called it more precise discrete random variable. Why discrete? Because we get it by counting. We count how many H, no H, we write 0. We count how many H, we have 1 H, so we write 1. And we count 2H, that's why we write 2. So it is discrete random variable. Why random? Because we get this outcome by random process, which is probability experiment. So we call this discrete random variable. Clear?
ممكن دكتور
Yes.
ليش اخترت الى كل اللي هو احتمال رقم معين مثلا 0 1 و2 ليش كذا يعني هل تختار لهم اي رقم يعني ولا كيف؟
This is not this is not probabilities. This is number of how many H's. I denoted X, number of H. Me, I denote X is number of H. So how many H is here? No H, so it is 0. How many H here is 1? How many H here is 2? For you, maybe X is the number of T's. Maybe.
طيب
Up to
وعلى
you.
اساس
It's up
اختار؟
to you. It's up to you, but you get this same.
اوكي.
This is the definition of random probabilities. Let's move. We always usually denote it by capital X. Actually, we have discrete and continuous, but for this chapter, we only discuss about discrete. Next chapter, inshallah, chapter 6, we are going to discuss about continuous probability distribution. Discrete probability distribution, we know from lecture 1. Discrete, we get it by counting. Continuous, we get it by measuring, right?
Right.
Let's take example of discrete. Number of traffic accident in a city. Yes, it is discrete. Why discrete? Because we get it by counting number of traffic accident, number of cars embarking, also get it by counting, number of head obtained by throwing a coin 3 times, number of defective engine, also number of customer entering restaurant during a given hour, also like number. So no fraction, no decimal. Okay.
Okay.
Now let's explain what is discrete probability distribution. Discrete probability distribution consists of 2 rows. 2 rows. First row is the value of x. Value of x. Second row is probability associated with each value of x. For our previous example about tossing a coin 2 times, the value of x was 0, 1, and 2, right? Now we are going to find probability of 0, probability of 1, probability of 2. Probability of 1 is, probability of 0 is,
0 ما في احتمال.
no, let's go to the sample space. Sample space is
T and T I think was.
yes,
1/4.
yes, T and T, H and T, T and H, H and H. From here, we are going to find the sample space. Actually, we have 4 points, so we divide over here. We divide over 4 because we have 4 points in sample space. We also divide over 4. Here we also divide over 4. So here we have how many points? We have 1 point, so it is 1 over 4. Here we have 2 points, so it is 2 over 4. Here we have 1 point, so it is 1 over 4. We call this discrete probability distribution. Why discrete? Because we are talking about discrete x. First row is discrete. Second row is probability of this discrete. So we called it discrete probability distributions. Clear?
Clear.
Discrete probability distribution consists of like two rows. First row is possible value of x. Second row is probability associated with each values of each value of x. X1 probability of x1, x2 probability of x2 till xn probability of xn. For our example, we have x1 equal 0, x2 equal 1, and we xn, the last value is 2. B of 0 was 1 over 4, B of 1 was 1 over 2, B of 2 was 1 over 4. Also, we can make a probability diagram for this frequency distribution, for this discrete probability distribution. If we go back to our example here, we have example of coin 2 times. We already construct discrete probability distribution like this. X and B of x. X was 0, right? 1 and 2. It was 1 over 4, right? This 2 over 4, this is half, and here is 1 over 4. So we can draw a probability diagram like this. It's x-axis. Next axis, we draw the value of x. Let's make it here 0. It's okay, no problem. Here can be 1, and here is 2. So for y-axis, we draw the probability of x. B of 0, you can divide it like 1 over 4, 1 over 4, 1 over 4. Here it's half. This could be 3 over 4. And this could be 1. So for 0, we have 1 over 4, right? For 1,
Right.
for 1 we have half. For 2, we have also half. So we call this probability diagram. Probability diagram. It's clear?
Clear.
In general, like this. Y in x-axis, we draw the possible values of x. For y-axis, we draw probability for each value of x. We call this probability diagram. Let's have example. This example available in page 220, example 5.3. If experiment of tossing coin 3 times, construct a probability distribution for the number of getting a hit. So now x is number of hits. X is represent number of hits. We toss a coin 3 times, right? 3 times number of sample space is 2 power 3. 2 power 3 equal 8, right? So possible value of x can be 0. 0 means what? No h. X could be 1, right? 1 h.
Right.
Yes,
X could be 2.
Could be 2.
S3.
And 3. 2, 3 is the maximum possible value of x. Now, we already determined the value of x. We have to find corresponding probability for each value of x. Let's go to free slide to find probability of each value, b of 0, b of 1, b of 2, and b of 3. B of 1 means what? B of 1. B of 0.
There is one variable, or there's one sample space with 0 heads, I think.
Yes. How many outcome with 0 h?
1, because there's only one with 3 tails, no heads.
Yes. So x take which value? X take 0. Yes. X take 1. X take 2. And x take 3 as maximum value. B of 0, we go direct. 0 means what? 0 means T, T, T. T, 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 no H. So how many points with no H? 1 point. So it is 1 over 8. Actually divide all over 8. Over 8. Over 8. Over 8. Then we come to find how many points with 1. How many points with 1? T, T, H. This first point. Second point is H, T, T. Third point is T, H, T. For all these 3 points, we have 1 H. You know, 1 H in different order. H in third, H in 1, H in 2. So we have three outcome with 1 H. How many outcome with 2 H? 2 H is 2 H and H and T. T, H and H. H, T, H. This is all possible of getting 2H, one rolling, one tossing a coin 3 times. So we have 3 outcome with 2H. Finally, how many outcome with 3H? When, right?
Yes.
So this is the discrete probability distribution for experiment of tossing a coin 3 times. Is it clear?
Yes.
Okay, which is this? First, this is the outcomes. No H, 0H, this outcome. 1H, these 3 outcomes. 2H, these 3 outcomes. X equal 3, 3H is H, H, and H. Probability for X equal 0 is 1 over 8. Probability for X equal 1 is 3 over 8. Probability for X equal 2 is 3 over 8. Probability for X equal 3 is 1 over 8. We call this discrete, because X is discrete, probability distribution. Clear? If they ask to draw a probability diagram for this, we go to x-axis and y-axis and draw like this. This is x, this is y, value of x 0, 1, 2, and 3, right? Then we can divide this to 1 over 8 is 1 over 8, 2 over 8, 3 over 8, half, and so on. For 0, we have 1 over 8, right? For 1, we have 3 over 8, right? Here we have 3
Sorry.
over 8. For 2 also we have 3 over 8. For 1 we have 1. For 3 we have 1 over 8. So this is probability diagram for discrete probability distribution when tossing a coin three times. Here is a probability diagram for the number of hits in 3 toss of a coin. Now we have 2 conditions for discrete probability distribution. These 2 conditions is summation of probability should be equal 1, and each value should be between 0 and 1. Let's go back to see. For example, if we find summation of b of x, 1 over 8 plus 3 over 8 plus 3 over 8 plus 1 over 8, summation of these probabilities 1 over 8 plus 3 over 8 is 4 over 8. 4 over 8 plus 3 over 8 is 7 over 8. 7 over 8 plus 1 over 8 is 8 over 8. 8 over 8 is 1. So first condition, summation of p of x should be equal 1. Should be equal 1. Second condition, 0 less than or equal b of x, less than or equal 1. Less than or equal 1. This means what? Each value here should be positive, not negative. and should be less than 1. 0, yes, can be 0. For example, if we write here 4, we get 0 because this gonna be impossible event. So all this value should be between 0 and 1. Can be 0, yes, can be 1, but cannot be greater than 1 or less than 0. These two conditions should be satisfied in order to say this is discrete probability distribution. Clear?
Clear.
So let's see. This is the two conditions. Let's take example. Now determine if the following are probability distribution or not. For A, don't care about X. All conditions are about probability of X, not about values of X. So here just we come to check two condition, which is summation B of X. Two condition, both should be satisfied, not one of them, both. 1 over 5 plus 1 over 5 plus 1 over 5 plus 1 over 5 is 5 over 5. 5 over 5 is 1. So first condition satisfy. Second condition, does 0 less than or equal B of X less than or equal 1? This satisfy or not? This condition satisfy or not? Yes, satisfy. All these values in between or equal 0, less than or equal 1. So yes, this is discrete probability distribution because satisfies the two condition. For B, a first condition, yes, satisfy. Summation of these values equal 1. Yes, this satisfy, but this condition is not satisfied because we have one value less than 0, negative. So this condition is not satisfied. Once one condition not satisfied, so this is not a discrete probability distribution. Clear? For the third one, we come to check first condition, does summation of this probability equal 1? Let's make it like all over 16. For the first will be 4 over 16. 4 over 16 is the same like 1 over 4. Here, 1 over 8, we can make it 2 over 16, right?
Right.
16 is same, plus 1 over 16, plus 9 over 16. So now just we do summation. 9 over 16. So 4 plus 2 is 6, 6 plus 1 is 7, 7 plus 9 is 9, 7 plus 9 is 16, 16 over 16 is 1, right?
Yes.
So first condition, satisfy. Second condition, does all this value in this interval, 0 less than or equal B of X less than or equal 1? Yes, we don't have negative, we don't have value greater than 1. So yes, it is discrete probability distribution. For the third one, for the D, the last one, let's check the first condition. Does this summation equal 1? No. 0.5 plus 0.3 is 0.8. 0.8 plus 0.4 equal 1.2. 1.2 is greater than 1. So first condition is not satisfied. So this is not a discrete probability distributions. Clear?
Clear.
Now, just try to solve this according to previous conditions. We have this discrete, already mentioned this is discrete probability distribution. If this is discrete probability distribution, so two conditions should be satisfied. B of X should be equal 1. Summation B of X should be equal 1. So we need to check. They ask about value of A. Value of A, according to this condition, this summation should be equal 1. So A plus 0.25 plus 0.5 should be equal 1, right?
Yes.
From here, A should be equal 0.25, right?
Yes.
So does 0.25 in between 0 less than b of x less than 1? Yes. Yes. So value of A is 0.25. If we write here 0.25, yes, it is discrete distribution because this summation equal 1 and all this value is positive and less than 1. Clear?
Clear.
Now we can take break and come back. Now it's break time, just 10 minutes and we back, okay? Okay, before class we discuss about discrete probability.
دكتور الصوت مو واضح.
طيب كده.
الحين مضبوط.
طيب before class discuss about discrete probability distribution. We take example of tossing coin 3 times. We write sample space S. Sample space equal sample space. We write sample space like TTT. Remember HTT and THT and TTH, HHT, THH, HTH, and HHH. We denote X as a number of H's. Then we construct discrete probability distribution consists of 2 rows. First row is values of X, value of X 0, 1, 2, and 3, right? Then we find probability of each value. 0 was 1 over 8 because we have 1 point, which is this point. 1 is 3 over 8, 3 over 8, 2 also 3 over 8, and 3 is 1 over 8, which is this point. We call this discrete because X is discrete, probability because we use probability, so it's discrete probability distribution. We have 2 conditions for this. First condition, summation of P of X should be equal 1 and 0 less than or equal P of X less than or equal 1. If these 2 conditions satisfy, we call this discrete probability distribution. Here summation of these values, summation of P of X for this example equal 1. Also all values of P of X is in between 0 and 1. So it is a discrete probability distribution. This is all about what we discussed before class. Now we are moving to take this example. Selman estimates the probability given in the following table for the number of cars sold per week. Okay. Value of X 0, no car sold, 1 car, 2 car, 3 car, 4 car, 8 cars, 5 cars. So now we are going to find probability of 0 cars is 0.05. here 0.12, 0.33, 0.28, 0.15, 0.07. If we ask, does this discrete probability distribution or not? Is it discrete? Just we go to find B of X. B of X is equal 0, it's clear. Can use calculator. Does each value of B of X is in this 0 less than or equal B of X less than 1? Yes, each of these value is positive value and no value greater than 0. So two conditions satisfy this is discrete probability distribution. Now the question is, find probability of having more than 3 cells. More than 3 cells. More than 3 cells can be written like
3 و4 عندنا.
yes, can write it in mass like probability of X greater than or equal 3. Instead of writing all these details, just we write find probability of X greater than or equal 3. Greater than or equal 3 is what? No, it's greater than. It's not greater than or equal. It's just greater than. This is greater than. So greater than, just we go to find probability of B of X equal 4 plus B of X equal 5, right?
All right.
B of X equal 4 plus B of X equal 5, which is 0.15 plus 0.07, since it's equal 0.22. So it is 0.22, right?
Okay.
Right.
Now we are moving to question B. Question B is find probability of at least. How to write at least? Like greater than, less than, in mass. At least means what?
على الأقل يعني أقل شيء.
Oh, -0.
Yes, at least one. Yes, great. At least one means what? Means B of
1.
X greater than or equal 1. Right?
Yes.
Yes.
B of X greater than or equal 1 equal what? Equal 1 minus B of X less than 1. Because this is the complement of this.
يعني 1 ناقص
Greater
0.
than, we make it less than. We don't write equal because equal is written here. So the complement no equal. So
1 ناقص 0.05.
yes, so it is 1 minus B of 1 minus B of 0, B of X,
0.95.
which is yes, 1 minus 0.05, 0.95. This can be done also by finding B of 0, just like this. This less than this at least 1 1 plus B of 2 plus B of 3 plus B of 4 plus B of 5, but it's like long story. Instead of this, we just find B of what? Find B of 0. Why we find B of 0? Because we know summation of all this from here to here, this summation should be equal 1, right? According to discrete probability distribution condition, this should be equal 1. So they ask about this, right?
Yes.
So if I just subtract this from 1, I will get this. Clear? Clear?
Clear.
Clear.
So let's move to 4, 3, see. What is probability of selling at most? Yes, this is a good question. Now discuss at most, at least. At most means what?
أكثر
Less
من
than or equal 4.
Yes. So just write like we write probability of for C B of at most means X less than or equal 4. Less than or equal 4 complement is what? Is 1 minus B of, here less than we make it greater than. B of X greater than 4, right? This equal 1 minus B of greater than 4 is X equal 5. 5 greater than 4 means 5. So it is 1 minus 0.07, which is 0.93. Clear? Clear?
كيف يا دكتور مو الاتموست من 0 إلى 4؟
Yes, at most this way, at most from 4 to 0, right?
مو تجمعهم في البداية تطرحهم من 1.
No, at most means B of 0 plus B of 1 plus B of 2 plus B of 3 plus B of 4 plus B of 4.
زين
So you have
لما
to find-
تجمعهم وبعدين 1 ناقص المجموع مفترض
no, at most 4 means 4 or less. So it is B of 0 plus B of 1 plus B of 2 plus B of 3 plus B of 4. This can be done by easy way because I know summation of these probabilities equal 1, right?
اوكي
I know. So they ask about all this from 0 to 4. This is the question. For this, include 5. All this, I know it is 1, right?
عدل
How to get this? 1 minus this, right? When all minus B of 5, we get at most 4.
اوكي
So
تمام
at most 4 is 0.97. This 0.97 can be done by B of 0.05 plus B of 0.12 plus B of 0.33 plus B of 0.28 plus 0.15 is equal 0.93. But this is easy way. Clear?
ليه
So we finish, we done this, we done this, we done last one, it is 0.93. We can do it like this, still we can get this, or we can do it in easy way, just 1 minus 0.07, this is 0.93. Now we are moving to new topic. Let's discuss this by adding new slide. And let's take last example about tossing coin 3 times. 3 times, so we have X and B of X. X equal 0, we have 1 over 8, right? X equal 1,
Right.
we have 2 over 8. No, it is 3 over 8. X equal 2, we have 3 over 8. 3 over 8. X equal 3, also we have 1 over 8. Now, we are going to find how to find mean and variance. You know mean and variance. But now,
المين دكتور تجمعهم تقسمهم على عددهم
yes, it was like this. It was like X bar equal summation X over N, right?
عدل
Here, in this discrete, X bar equal summation X bx, summation x bx, x bx, x bx, x bx, x bx. So we just multiply 0 by 1 over 8, plus 1 by 3 over 8, plus 2 by 3 over 8, plus 3 by 1 over 8. But just like this, 0, x equal 0, b of x equal
1 over 8.
Plus 1 multiplied by
3 over 8.
3 over 8 plus 2 multiply 3 over 8
And 3 multiplied
plus
by
3
1 over 8.
multiply 1 over 8. This equal here 3 is 0. Okay, leave this 0. This is 3. 3 plus 6 9. 9 plus 3 is 12. So it is 12 over 8.
نبسط يا دكتور ولا ما يحتاج؟
Is you can write it like 3 over 2. Okay, 3 over 2. So if we toss a coin 3 times, we expect the number of h to be 3 over 2. 3 over 2. So sometimes they don't ask about mean, they ask about find expected value. Expected value is mean, same expected value. Expected value means what? Means x bar. Or they might ask about expectation. Expectation also is same like mean. Mean, expectation, expected value, or are same. Now clear?
Clear.
Okay, now let's see how to find variance of this example. To find variance, we have
القانون يا دكتور، في قانون حق هذا ولا؟
القانون هذا هو القانون right؟
لا نتكلم عن الفارينس.
نتكلم عن الفاريance. Yes, we have I want to write to you but yes we have just now mean is clear right? How to find mean, just we multiply it.
هل بتطلب يا دكتور الستاندرد ديفيشن بعد الفارينس موجود يعني؟
Yes, to find standard deviation we need to find variance first. Then
لو square root of variance هو.
yes, but let's try how to find variance. Variance sigma square equal summation, sorry, expected value of x square minus expected value of x all square. Expected value means what? Before x bar is expected value of x. Expected value.
يا دكتور ولا؟
Yes, it is same. Expected value of x, we get it by finding summation of x dx. Summation of x dx. How to find expected value of x square? Same. Instead of x, just we use x square. Summation x square multiplied by b of x. So how to find this? X square, expected value of x square equals summation x square multiplied by b of x. The same like expected value of x, we multiply x by a b of x. Now we are going to multiply x square by b of x. Yes, we can make it easy. Construct new row. Give it x square. X is 0 square is 0, right? 1 square is 1. 2 square is 4. 3 square is 9. Now we are going to use this column, this one, this row with this row. Similar like when we use this with this with this. So expected value of x squared gonna be 0 multiplied by 1 over 8, right? Plus 1 multiplied by 3 over 8 plus 4, right? 4 multiplied by 3 over 8 plus 9 multiplied by 1 over 8. Clear? Same like instead of using x, just we use s squared. 0 squared is 0, 1 square is 1, 2 square is 4, 3 square is 9. Now 1 by 3 is 3, right? 3 by 3, 4 by 3 is 12. 3 by 12 is 15, right? 15 plus 9 is
24, right?
24 over 8. Okay, now we get expected value of x squared. Sigma square variance equal expected value of x squared minus expected x. We already get it. Expected x is the mean. Expected x all square. So we just do substitution. Sigma square equal. We already get this first part. 24 over 8. Second part was 3 over 2, right?
Yes.
3 over 2 square. 3 over 2 square. So it's 24 over 8 minus 9 over 4, right? Equal
Yes. 6 over
6 over 8.
6 over 8.
yes, 3 over 4, right?
So does it mean we don't equalize the denominator beforehand?
What?
ما نوحد المقام قبل ما نسوي تربيع.
No, it is same. Just make it. It is 6 over 8. 6 over 8 is 3 over 4. Right?
Okay.
It is 8. Here it is 18 over 8. 24 minus 18 is 6. 6 over 8 is 3 over 4. Clear?
Okay.
So 3 over 4 is the variance. If they ask about find standard deviation sigma, I know sigma is square root of sigma square. So for our example, sigma is square root of 3 over 4. Clear? Clear?
كبير يا دكتور.
So now this is formula for getting mean, expected value, expectation, mu expected value is summation of x bx. How to find variance, var x, the variance of x, or sigma squared, expected value of x squared minus expected of x all squared. Standard deviation is square root of variance. In order to find variance, we need to find mean. In order to find standard deviation, we need to find variance. Let's take this example. Here question is find the mean of breakdowns. How to find the mean?
EX sigma EX PPX.
Yes, just expected value of x equals summation x px, which is 0 multiplied by 0.064 plus 1 multiplied by 0.288 plus 2 multiplied by 0.432 plus 3 multiplied by 0.216. Yes, this is the mean. Easy way, right? You can use this like It's just for explanation, but it is easy. Just we do like x by x, x by x, we get 1.8 in 1 minute. We don't need to do all this. Now, question is find mean, variance, and standard deviation for the following discrete probability distributions. How to find mean?
Sigma x px.
Yes, this question can be done like this. Just find what? Find standard deviation. To find standard deviation, you need to find variance,
Correct.
right?
Yes, we
To
need
find
to
variance, you need to find
mean.
mean. So just this question can be find standard deviation, and you need to find all mean and variance. How to find mean? You just multiply 8 by 0.05, 9 by 0.3, 10 by 0.3, 11 by 0.2, 12
And some
13, and find the summations. Then we go to find x squared. This is x. Here we find x squared, 64, 81, 100, 121, 144, right?
yes.
And here we have 169. So for finding some expected value of x squared, we need to find summation x squared bx. So we use x squared, this x squared, instead of using x. So we multiply 64 by 0.05, 81 by 0.3, 100 by 0.3, 121 by 0.2, 144.13, 113, and 169 by 0.02. After we get this, we go to find we use the formula expected value of x squared minus expected value of x all squared. So after we get in this, for getting standard deviation, just we find square root of sigma square. Let's see the solution. For expected value, just we multiply x by b of x, we get this. For sigma square, we need to find expected value of x squared. So instead of using 8, we use 64. Instead of use 9, we use 81, and so on. Then we subtract this value from this square according to this formula. In order to get standard deviation, just we find square root of variance, which is 1.177. So this is standard deviation. Is it clear?
Yes, clear.
Now let's see this example. Example 518, page 214. A company has established statistic on the intervention necessary for the maintenance of machine for 1 year. 50 identical machine. It obtained the below table. So this table consists of 2 columns. First column consists of number of interventions. The second column is the number of machines. So let's see the question. Construct the probability distribution for the random variable. Actually, this is discrete random variable because it take discrete values 0, 1, 2, 3, and 4, and it is a number, so it is a discrete. Now, this also number, this is not probability distribution, so we need to convert these values to represent a probability distribution for this value. How? Just if you remember before, we used to get relative frequency by divide frequency value for the total number of all frequency. So just now we divide 4 over 50, 25 over 50, 12 over 50, 6 over 50, and 3 over 50. So We get 4/50 is 0.08. 24/50 is 0.5. 12/50 is 0.24. 6/50 is 0.12. 3/50 is 0.06. So now let's check, is it a discrete probability distribution? If it is a discrete probability distribution, so two conditions should be satisfied. First condition, summation of P of X should be equal 1. Second condition is 0 less than or equal P of X less than or equal 1. Okay, let's check. 0.08 plus 0.12 is 0.2. 0.24 plus 0.06 is 0.3. Plus 0.05 equal 1. So first condition satisfied. For the second condition, just we need to check all this value is positive and all values is less than 1. So second condition also satisfied. So it is a discrete probability distribution. Second question, find expected value of X. Expected value of X. Expected value of X. We already know expected value of X equal summation X dx. Direct, we just multiply 0 by 0.8, 0 multiply 0.08 plus 1 multiply by 0.5 plus 2 multiply 0.24 plus 3 multiply 0.12 plus 4 multiply 0.06. So we get 0.5 plus 0.48 plus 0.36 plus 0.24. So this is 0.6. This is 0.6 plus 0.48 is 1.8. 1.08. 1.08 plus 0.5 is 1.58. So 1.58 is the expected value for this discrete probability distribution after we convert this number to these probabilities. So now let's see. So compare these values to this value. Now already we have this discrete probability distribution. We already check summation of this value is equal 1. And all this value is greater than 0 and less than 1. So two conditions satisfy. Expected value already use this formula. 0 multiplied by 0.08. 1 multiplied by 0.5, 2 multiplied by 0.24, 3 multiplied by 0.12, and 4 multiplied by 0.06. We get this. This is expected value of this discrete probability distribution. We just have to know this formula used for discrete probability distribution. So first we need to check, is it discrete probability distribution? For this, yes, we already compare this to a discrete probability distribution. Then we use this formula to get the expected value of X. For the variance, just we need to use to find X squared. She is Square of 0 is 0, square of 1 is 1, square of 2 is 4, square of 3 is 9, square of 4 is 16. So we need to find expected value of x squared by multiplying 0 by 0.08, 1 by 0.5, 4 by 0.24, 9 multiplied by 0.12, 16 multiplied by 0.08. After getting this, just we use the formula, which is sigma squared equal expected value of x squared minus expected value of x all squared. After we get this is 3.5. 3.5 is subtracted by from the square of mean. We already get mean 1.58. We get expected value of x squared is 3.5. So 3.5 minus 1.58 all square gives this. So this is the variance. For standard deviation, we just find the square roots of variance. We get this. This is the standard deviation of of this discrete probability distribution. Clear?
Okay.
Now we are going to last example. 1,000 tickets are sold. Each ticket with 1 real. For what? For a cell phone valued at this cell phone price is 500. What is the expected value of the gain if you buy 1 ticket? If you buy 1 ticket, maybe you win, maybe you lose, right? Because there are 100 tickets, 100 person will buy these tickets, right? So a probability you get success, like you get this price, is 1 over 1,000. Why 1 over 1,000? Because actually we have a total of 1,000, right? If you got the price, then actually you pay with 1 real, right? You actually pay 1 real, and you will get 500. This phone, cell phone, with 500. So actually you get 499, not 500, because you already pay one ticket, 1 real, right? Clear?
Clear, Doctor.
But if you lose, you will lose your real, right? So you lost your real. This with probability of 999 over 100. Because it's the
دكتور
complement of this.
ما فهمت ليش يعني صار واحد كيف تلوز يعني كيف تخسر واحد ريال واحد يعني
It already you pay 1 real, right? You buy 1 ticket and you get nothing, right? So you lose your real. You lose like minus. You lost your 1 real, right?
right.
Probability you win, you get the cell phone is 1 over 1,000. Probability you lose is 999 over 1,000. This is a complement of this. Summation equal 1, definitely. So now find expected value. For finding expected value, just we multiply x by b of x. 499 multiplied by 1 over 1,000 minus 1 multiplied by 999 over 1,000, we get this. Now we finish the class. Maybe we have time, 10 minutes, right?
Yes.
Is it clear? Or maybe you can move to give you other example like activity. Let's take activity. If we roll a die 2 times, sample space will be 36, right? 36 is 6 power 2. Let x denote sum of the two faces on the die. Two faces on the die. On the dies. So we roll a die 2 times. X is the sum of the upper face of the 2 die. What is the possible value of x? Possible value of x. X can take which value? X take die. Die has 6 faces. 1, 2, 3, 4, 5, 6. Second die also have 1, 2, 3, 4, 5, 6. We roll 2 die 1 times. X equal summation of 2 faces on die. For example, if I get die first die and I get 1 from first die and 1 from second die, summation will be 2, right? Clear?
ليش اثنين يا دكتور؟
If I roll first die and I get 1, first die I get 1, second die also I get 1. So in this case, summation equal 2, right? Right?
So the minimum would be 2 and the maximum would be 12.
Yes, exactly. So possible value of x is what? 2 to 12. 2 to 12. Now we are going to find probability of each value of x. P of x. P of 2 come.
2 over 36. Or wait.
Yes. We divide all over 36. How many points?
I think it's 1 over 36.
X equal to 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, right. So first we will divide all over 36. Why? Because sample space is 36. Then we come to find how many points can get 4, how many point we can get 6, and so on. Over 36, over 36, over 36, over 36. This can be exam questions, but let's see. How many points? Just 1 point. How many points we can get? 3. 3 just 2 points. Why 2 points? Because 1 and 2, 2 and 1. How many points we can get? 4. 3 points.
4, I think.
No, it is 3. 3 points is 1 and 3, 3 and 1, 2 and 2. How many points you can get? 5, it is 4. How many points to get 6? It is 5. How many points to get 7? It is 6. How many points to get 8? 5, 4, 3, 2, 1. To check summation of bx equal 1. 1 plus 2, 3. 3 plus 3 is 6. 6 plus 4 is 4. 6 plus 4 is 10. 10 plus 5, 15. 15 plus 6, 21. 21 plus 5, 26. 26 plus 4 is 30. 30 plus 3, 33. 33 plus 2, 35. 35 plus 1, 36. 36 over 36 equal 1. So each value greater than 0 and less than 1. So this is the discrete probability distribution when rolling a die 2 times. And X defined as the sum of the two faces on the die. Other question can be find expected value, variance, and standard deviation. So just we stop here. Clear?
Clear.
Clear.